and inspired to look up a little bit more into the water damage and the PCB itself. Yes, so I did some research, found a few quite nice blogs or sites where people were describing the internals of this toothbrush, and yeah, this helped a little bit too. And I wanted to make a little video about describing what are the components, how they interact, and yeah, show some possible repairs. I will not be doing these repairs on video for some time now, because yeah, I got some new gear, nice microscope with camera, and in future I will be able to show you guys close-up videos of that kind of a small repairs where you need to replace some of the chips or look for the damage and so on. But I found out, yeah, okay, I could have found out earlier, but I found out only now that the cheapo camera that is mounted on this microscope doesn't have any SD card port or some other means how I could record my videos. So now I ordered a HDMI to USB converter, and will need to wait till it arrive. Okay, so with this said, for now I can still explain some of the damages that you could use and maybe fix your toothbrush. Okay, but first let's talk a little bit about the internals of this toothbrush. So yeah, we have as you know, this part, yeah, electromagnet, magnet, all this, okay, and then we have controls. In principle, what we have is a simple, not simple, quite a smart microcontroller with yeah, integrated resonator, programmable contacts, and analog to digital analog to digital converters, as I read in one interesting blog that I will link in the description, and it yeah, controls the charging, the toothbrush itself. Charging is done with a wireless coil that is charged with the AC current and quite high frequencies, 80 kilohertz, I believe, and it forms like something from 5 to 12 volts AC current that is then converted to the DC current, and I think with this transistor it is being charged to the battery. So this chip controls this transistor and then controls the charging. Then what we have, yeah, so I didn't find out all of the chips till now, but only the main parts. Then what we have is these double MOSFETs that form the H bridge that can control the current flow into the electromagnet by switching two switches at one time, and then enabling the current flow into one another direction, so you get bigger oscillations. Because I think one is the positive MOSFET, the other makes the current in negative. But yeah, don't take this as 100%. You can check this guy's blog and research by yourself. Still need to get a oscilloscope to check some of these things, but yeah. Okay, and yeah, then we have the programming pins that are not that needed, but yeah, they're there. And we have this button. Yeah, it's disassembled, but this is in principle the button. It's a simple two contacts that are being shorted by a small metallic plate. Here it is. Okay, dropped it. Let's take another one. I have a few of these. Yeah, then we have, oh, come on. Yeah, this metallic plate. Okay, that is placed on this side. It's a little bent out, so when you press it, this metallic plate is being pressed down to short in these 2 points. And yeah, on top we have one more metallic plate as a button and the housing itself. Yeah, so in principle with microscope it's possible to disassemble it and clean it. I will come back to this a little bit later, but without it and even with microscope it's very difficult job to get at this button. I tried to replace one button. Sadly, it's not easier. Yeah, these soldering points, they are incredible tiny, and the replacement button is almost the same as original, but still the legs were much going out of the soldering pads. So yeah, not an easy answer for this, but it's possible to repair, it's possible to exchange, but you will need some special equipment. Of course, even for the desoldering, hot air is much better than the soldering iron. Okay, so now let's talk, or let's say you have a water damaged toothbrush. What can you look for and what can you check to see what is the damage? First of all, you will have to take off all the components, not components, desolder the bridge that powers up the whole board. Then you will desolder this bridge. Then you can desolder the battery contacts and take out the battery. Then desolder the charging coil. Be very careful with this. You shouldn't heat it too much because it is these 2 pins are going through this plastic casing, and here it connects to this coil. And if you heat it too much, the plastic would melt and it will be quite wobbly. It should be working okay, but yeah, still try to keep the heat as little as possible. Then you should trim these 2 plastic pins, and by loosening these 2 clips, you lift it up and you take out and see something like this. Yeah. Yeah, as I said, I have a lot of these water damaged motherboards, and try to clean it in ultrasonic bath. Clean it only once for like 5 minutes. So I think I will repeat this process of cleaning it in the ultrasonic bath, and afterwards cleaning it with isopropyl alcohol. By doing this, I was able, from a lot of dead motherboards, I got 3 or 4 working again, only by simply cleaning it once in ultrasonic bath. So hope to get a little bit more, but yeah, there are some dangers. So in this toothbrush is not that, or this PCB is not that watertight. It has a lot of throughout holes that corrosion affects them, and when you apply ultrasonic cleaning, it could the water or cleaning solution could get under this safety layer and damage your board even more. So yeah, but okay, you don't have what to lose if you already have water damage. So this is the first step. Clean it with, if you have only toothbrush, clean it with toothbrush. Check all the pins that it wouldn't have some corrosion between these, so it wouldn't short out. Then what we have, and let's say another symptoms is if you have to press your toothbrush button very strongly, and then it turns on. This indicates, again, first of all, it's water damage, some water and toothpaste got down to this button. If this button gets contaminated, this metal plate gets some gunk on this side, and that's why when you press really strongly, it usually, or not usually, it could start, and that's the indication that this button is contaminated. Yeah, how you can check this when you take it out and so on. You can take simple pliers and shorten these two buttons. If by shortening it, or you can, okay, a more scientific way, if you have a multimeter, get into a continuity test and try to, by applying multimeter at these two legs, with the third hand, press the button. If it has a low resistance, 1 ohm or something like this, it will beep and the button is okay. But what I predict is you will have some resistance measurement, and if you press it strongly, it will go into the beep and yeah, turns on. So this indicates that the button is contaminated, and you could fix this defect by taking apart it, cleaning, or replacing this button. Maybe with ultrasonic cleaning, maybe it will help out a little bit, but what I'm afraid is that, and what I will have to check all of these boards, that some of the cleaning solution, of course, when you bat it in the isopropyl alcohol, you could afterward when it's laying in the alcohol, you could press down the button so the liquid that was used for cleaning would get out, and alcohol would get in. It's much easier to get rid of the alcohol than water from this button. It's not waterproof, as I said before. So yeah, this is one thing. And what I found out, another interesting defect that these toothbrushes has, as I would say the most common defect when you get water damage, is simple corrosion on one track. That one track is the turn on button track. This is exactly the case with this toothbrush. As you can see, everything looks very nice. You don't see any corrosion, but when you flip it over, you can see some corrosion on this end. And yeah, I have a picture of all these my motherboards before cleaning. Usually the more contaminated is the backside of this toothbrush. Behind this plastic, water stays longer, and corrosion process is more severe than on the outside. You could say that it's good, all the components are on the upper side, but problem is we have this one small trace going down here, and this is the button terminal that that's how your microchip understands that you pressed this button. To test this, you can do following. Put your meter into continuity and check between this pin. Look up if you can see. Yes, it's between this pin and between this one. Right next to the R1, this pin is the there's this line that goes underneath the other side. So if we check continuity between these two pins, on this one I don't get anything. On the toothbrush that functions, these two pins are working, or we have continuity between these two pins, so it means the wire goes through. Yeah, the same as here, because yeah, this one is already repaired. It had the same defect, but on this one we have continuity. Everything works as it should work, and even if the backside looks like this is something unbelievable. So, and as you can see, this is the trace where it goes down, so it has a lot of corrosion, but it's still working. So I will need to repair it too, just to be sure that it will stay working. So, and yeah, that's how you can test it if you don't have continuity between these points. Then one more, if you don't have a multimeter, yeah, you can test it in one more way. You take a simple wire, place it at this leg of the button, and then shorten it into the position of this R1 test point. As you can see, now it functions as a button. So that indicates that you have a damaged connection in this this point, and yeah, you can do anything you want. You can take a wire and solder it from this test point to this connection. It's possible to do this too, but I found that maybe a more elegant solution, when you will get a PCB out, you will have access to the back side of the board. You can strip down this small contact area of this trace, solder a thin wire to this, go into the other side of the board and solder it to this point. I was thinking I think I have one. Yeah, I have one without a button. If you take off the button, maybe it's even possible to go through this through hole. You'll still need to strip down this contact and go through with the wire through this hole and solder it to, yeah, in here or here. But in that case, the button will be slightly elevated. As you can see, it's quite flushly set. It contacts the whole area, and if you would go through this hole, it will be a little bit slightly on the angle, and when you keep pressing it, it could damage this button again, this wire again. So for me, more durable, I think the solution is to solder the wire in this way. And then when you solder this wire, it should be working again, or not, because yeah, this you can test, of course, with a simple wire and see how the toothbrush behaves. If you have if this corrosion is the only damage that was done to your PCB motherboard, hooray, you fixed it, and everything will be normal, okay, again. But of course, it could be a lot more. It could be some shorts in MOSFETs. And let's say another defect that usually occurs. You press the button, it slightly lights up and then turns off again. This is my presumption, but I think this microchip checks the currents flowing through this power part, let's say it like this, and if it registers some higher currents, it shuts off. So that's why, or let's say some of my toothbrushes that I cleaned are now behaving like this, that you turn it on and let's say in 10 seconds it turns off, or 20 or 1 minute, and it's not predictable, but I think it's the a short exists still, or slightly let's say the shorting, some kind of component is still shorting, and that's why it behaves like this. It turns on, it works for some time, and then the current rises or something like this, and then the controller shuts the toothbrush down. So this is the majority of the PCBs that I still have, is that they turn on and then turns off in some time. So I still will investigate it further, and I think if I will find something interesting, I will make one more video about this water damage thematic. And yeah, okay, and one more. So okay, so we now talked about this button and the trace. This is one damage that you could find and easily fix. Other thing, what is first thing maybe that you should check if your toothbrush is dead completely, you should check this fuse. This fuse disconnects the whole battery, and yeah, again, it's I think it's even a resettable fuse, so it resets after some yeah, not sure how it really works. Is it it has some kind of amount of acting times, as yeah, as I have, I think, how much do I have? 11, yeah, 11 toothbrushes that this fuse was defected or burned through. So it's a resettable, but still it can burn through. So and I think by testing I even burned some on at my eyes when I was shorting this pin to this one. Some of the fuses burned. So yeah, don't do it if you're afraid to lose this fuse, but yeah, not sure how you could check it the other way. Yeah, and I ordered a lot of these fuses, and I will try to investigate the other boards too when the fuses will arrive. I don't want to short it and try to mess around with the board without the fuse, because yeah, if it's not protected, it could burn other components. I burned one MOSFET by turning it on, so anything can happen with water damage. Yeah, so these are two components that you should check when your board is acting weird with water damage or something else, because I saw one I done one repair for a subscriber that he sent me two boards. One was water damage, the other one was not sure, it didn't work. The subscriber told that it was both of them were dropped, but yeah, the funny thing was that I checked the fuse, and on the one that didn't showed any water damage activity, it was blown. So I took off the fuse from the water damaged main motherboard and placed it into another one, and it started to work without any problems. So yeah, for now, for water damage thematic, I have only two advices for you. Check the fuse and check the button and trace. That can be checked by shorting or checking continuity between this test point and this R1 throughout hole. Yeah, so hope this was helpful to understand more about this toothbrush and yeah, possibly fix some of the defects. And yeah, hopefully my adapter will come soon, and I will be able to show you some close-up of these repairs. And till that time, maybe I will find out even more defects that could be fixed. So thanks and goodbye.